similar, the same, the exact same. We got to be careful because in math, similar means a very specific thing, right? If I have similar triangles, their side lengths are proportional, but they are not the same size, right? Alex?
There's three different angles depending on like their size.
Okay, what types of angles are you talking about?
Acute angles.
Okay.
Right angles.
Okay.
And obtuse.
Okay. Liana?
I was gonna ask if something's the same, but it's like in that direction, is it still congruent?
If it's the same what?
If it's like the same shape or like same angle, but like it's facing in the direction. Say there was like a right angle, but like the point was facing the bottom left, and there was another right angle, but it was facing the top.
Like this?
Yeah.
Are these two angles congruent?
Yeah. Yes.
Yes. Because what does congruent mean?
Same.
The same, right? In this case, we're talking about the same angle measure. Doesn't matter if I turn it a little bit this way or a little bit that way, it's still a 90-degree angle either way. What's the fourth type of angle that always gets left off this list? A straight angle. How many degrees is a straight angle? 180. Obtuse is what? Greater than 90. Right is 90. And what's acute? Less than 90. It's a good start. What else do we know about angles? Tyler? You said what now? Reflex angles. Okay, what's a reflex angle, Tyler?
Like more than 180 degrees.
Ah, so if I have an angle like this, where I'm talking about this right there, good. Yeah, we're not going to talk about that necessarily, but that's good that you remember that. That's great. Ava?
Complementary.
What do you remember? Don't worry about all this. What do you remember?
Complementary angles.
What are complementary angles?
I don't remember.
Good. What are complementary angles? So, anyone remember what those are? Anthony?
Aren't those kind of like two adjacent angles? Kind of like.
Yes, they're definitely adjacent angles.
Like, isn't it like 120 degrees or something?
Close, a little bit smaller,
Like 110?
a little bit more smaller, a little smaller. Hey, look at that. There we go. Complementary angles that make 90. What'd you say, Ryan?
Supplementary.
Supplementary. There you go. You got it. You're on the right track. I knew what you were talking about. Supplementary. No, sorry. Now I said it. Supplementary. What did two supplementary angles? What do those add to? 180. All right. My bad. Let's come back together. Liana, what were you gonna add?
I was gonna say that supplementary angles are two adjacent angles with straight angles faced with like two opposite ways.
Very nice. Tyler?
Corresponding angles.
Okay, what are corresponding angles? Okay, so the question was, what do you remember about angles from last year, right? So that probably wouldn't fall under that. Reading off the notes I just gave you probably wouldn't fall under that, right, Liana? Is that all we remember? You guys don't remember anything else?
I remember interior angles.
Okay, now we're just looking at the wall. All right, so that's a lot of stuff we remembered. We're going to use some of that. I'm glad that we have a basic understanding, especially of complementary, supplementary. We're going to talk about some different types of relationships here. The first one being adjacent angles. Everybody say adjacent angles. What does it mean for two things to be adjacent to each other?
Two angles with a common vertex.
Next to. Okay, next to. My classroom and Miss Karan's classroom are adjacent classrooms. We are directly next to each other. We share this wall in the middle. Does that make sense? Whose classroom am I not adjacent to?
Mr. Hoggard.
Miss Henson, Mr. Hoggard. Yeah, way over there, right? I'm only adjacent to Miss Karan's classroom with this wall and Miss Chow's classroom with this wall, right? So in order for two angles to be adjacent, they have to share that center line. That's what we're looking at right here. Whoa. Okay? So if you imagine angle 1 is my classroom, angle 2 is Miss Karan's classroom, this orange arrow, or a ray, as we know it, is this wall that's in between the two rooms. Does that kind of make sense? Yeah, Alex, question?
So the wall that you have right now is like the same wall at Miss Child's side.
Yeah, this wall is the same wall, just on the different side of Miss Chow. It's not like they put one wall here and another wall right next to it. It's the same wall, it just has two sides of it. You know what I mean? Tyler?
Is there a hallway in between them?
No. Okay? So adjacent angles, they have a common vertex. What is a vertex? Uh-oh. We've talked about this in here. The thing. Good. Chloe.
So like middle.
Yeah, the middle, is it a line? Is it a, what is it? It's a dot. What do we call a dot in math? Hey, there we go. It's a point.
Oh, I thought it was like a corner or something.
No, a vertex is a point. A point in which at least two rays come out of. Right? So you're not wrong in saying it's a corner, but it's technically it's a point, right? This is the vertex right here. I'm going to do it in purple just so it's different. And a common side. Again, that common side is that one in the middle. What do two adjacent angles add together and equal? Think about it for a second. If I have two adjacent angles and I were to add them together, what is their combined angle measure going to equal? Any ideas? Alex, you got an idea? 180. It's a great guess. Any other ideas? 90. Another great guess. Well, what do 1 and 2 look like they add up to equal here?
Over 90.
Something over 90. Do we know exactly what? No. So that's the thing about adjacent angles, is they don't always add up to a specific number, like complementary and supplementary. Adjacent angles, we don't know what they add together to be. Now they could add to 90, they could add to 180, or they could add to anything in between, less than, more than. It could be anything. So the only thing we know about adjacent angles is they share that center line. That's it. Adjacent angles are not the focal point of what we're going to be talking about, so I wanted to get those out of the way first because they can be a little confusing. The next one is a linear pair. Can I get a volunteer to read out what a linear pair is for me? Let's, Anthony, go for it.
Two adjacent angles with a straight angle base made up of two opposite rays.
Yep. And then it says supplementary angles that add to what again?
180.
Everybody, what do supplementary angles add to?
180.
180. So linear pair is just another word for supplementary angles. Angles 1 and 2 in this diagram are definitely adjacent angles. They have that common side splitting them up. But the base of a linear pair is a straight angle. How much degrees is a straight angle again? 180 degrees. So think about it. If the left side here is 180 degrees, what does the right side have to be? This part right here. The whole thing's got to be 180. How many degrees is a circle? 360. So if half my circle is 180, the other half's got to be 180, right? Does that make sense? Okay. Which means angle 1 plus angle 2 has to equal 180 degrees. In this case right here, with a linear pair. Again, also called supplementary. I want to make you aware of all the different names it could be called. Now again, this is a type of adjacent angle. Not all adjacent angles form a 180 degree straight angle, but some of them do. Those that do are called linear pairs. Okay, everybody say linear pair. Linear pair. What does linear mean again? Straight line. So this is two angles that when you stick them next to each other, that's what I said, right? They form a line, a straight line, which is 180 degrees. Okay? Any questions on that one? Pretty easy, right? Vertical angles. Two non-adjacent angles formed by two intersecting lines. Non-adjacent angles. What does it mean for two angles to not be adjacent? Alex, what do you think? They don't have something in common. It's not the vertex. It's the side. They don't have a common side, right? For example, if I have angle 1 and angle 2, what do those two angles share? Alex just said it. They share a vertex, but they do not share a side. Right? This angle is like a V opening up this way. Angle 2 is like a V opening down that way. So they do meet in the middle, but they don't share a common side like adjacent angles would. Now, are 1 and 2, are those supplementary to each other? Will they add to 180? Well, what type of angle is angle 1? Acute, obtuse, right? What is it? Definitely acute. What about 2? Acute. Well, I can't have two acute angles make 180 degrees, right? That wouldn't be possible. Aaron? Because they're less than 90 degrees. Exactly. So I can't have two acute angles. So they're not supplementary. What might they be? What do you think? What's the word again? It starts with a C. It's written right there. Oh, sorry. Another C. Congruence. They're equal. I've got a good way to visualize this. Let's say these are my two lines, okay? And here is angle 1, angle 2, angle 3, and angle 4, right? Everybody visualizing that? Okay. If I take these lines and I move them like this, what is happening to angles 1 and 2? They're closing in. Are they getting bigger or are they getting smaller? They're getting smaller. What's happening to 3 and 4? They're getting bigger. What if I move my lines down this way? What happens to angles 3 and 4 now? They're getting smaller. What about 1 and 2? They're getting bigger. So when 1 changes, 2 changes in the same way. When 3 changes, 4 changes in the same way. You guys all see that? So that means that if I have two angles opposite each other like this, they're always going to be equal. Right? So that's what vertical angles are. For some reason, vertical angles always confuse students, but they're pretty straightforward. If I see them across from each other like this, I call them bow tie angles. Because if I look at it like this, right? It looks like a little bow tie in there in the middle. You see that? Okay, so if I have bow tie angles, they're going to be equal to each other. The left side of my bow tie has got to be the same size as the right. Okay? So here, angle 1 is equal to angle 2. You guys want to stay here or you want to go somewhere else? Davis, Aaron, you guys want to stay here or you want to go somewhere else? You want to stay here? Okay, bring it to me. It says angle 1 equals angle 2. Right here? Yeah, because they're congruent. Any questions on vertical angles? All right, so that's the basic stuff. Real nice and simple. Now let's look at something disgusting, like this drawing right here. Okay? There's lots going on with this. We got A, B, C, D, E, F, and then G right there in the middle. Okay? So let's see what information this gives me. This tells me that the ray GC, which is right here, bisects BGD. What does it mean? We talked about this before. What does it mean for a line to bisect an angle?
It cuts in half.
Cuts it in half, right? So if GC, I'm going to do it in purple, GC bisects BGD, that means this angle is equal to that angle. I'm going to do a single little angle measure marker to show that they're the same. I realized I made a typo, that's my bad. This next piece of information says BE and AD are vertical angles. It should say they make vertical angles. I apologize. Are you okay? So if BE and AD make vertical angles, right? This is what we were talking about like this. There's BE and AD making the vertical angles. What do I know about these two angles right here? They are the same. So for this one, I'm going to do a little double angle measure marker and a double angle measure marker, it's hard to say, over there, to show that now those two are equal to each other. But they are not equal to those purple angles up on the top. Okay, we also find out that GB and GE are opposite rays. That's GB and GE. If I look back at my definition for a linear pair, what do I know about opposite rays? What does that tell me? Look back at my definition. What does it say about a couple angles made up of opposite rays? They're a linear pair, which means together they equal what? 180. So I'm going to do a little dotted measure marker all the way across and denote that that is 180 degrees. We also know that GA and GD are opposite rays. So the same deal goes for them. They make a linear pair. Here's GA. There's GD. So all the way across, that's 180 degrees. So the name of the game here with this is knowing as much as you possibly can before you start trying to figure out what to do with the question. So if it gives you information like this, figure out what that information tells you first. That's going to make the problem that you're now going to solve a lot easier. Okay? Number 1 says, if measure of angle, that's what this means, M with that little thing is measure of angle. If the measure of angle BGC is 60, find the measure of angle CGE. Well, let's find where BGC is first. How can I find where BGC is? Just look at the points, right? Here's B, there's G, there's C, which means this little purple angle marker is BGC. So that, I know, is 60 degrees, because it tells me that. So if I know that's 60 degrees, I need to find what's the measure of angle CGE. Well, how do I know where CGE is? There's C, vertex of G, endpoint of E. So I'm looking at this angle right here in teal. How might I be able to figure out what that teal angle is? Aaron? Perfect. Exactly right. So I'm going to ignore this bottom half real quick. Right? If I'm just looking at this, the whole thing in pink is 180. This little section is 60. What's the remaining section? Well, I can just do 180 minus 60, and that gives me my remaining section, right? Great job, Aaron. Thank you for that. So if I could set this up, 180 minus 60 is going to equal the measure of angle CGE. So what is my measure of angle CGE, Alex? 120. 120 what? Degrees. Not too bad, right? Yeah? Any questions on that first one? Okay. Second one says, if measure of angle AGB is 47, well, where's AGB? AGB. So this double blue line is 47 degrees. Find the measure of angle EGD. Here's E, there's G, there's D. So I'm looking for this, again, this little double blue angle off to the right-hand side. Well, how can I set up an equation for this one? This one's a lot easier than number one, right? I know that this double blue is 47. I'm trying to find what this double blue is over here. What might I be able to do? Talk with your group. Take 60 seconds. How can I find out what that other angle is? Go. Oh, here we go. A straight line is always 180 from here to there. It's always 180. So, yeah.
Oh, so we have B 180 will be 180 minus.
It could be. I see why you're thinking that. All right. Raya, what'd you guys come up with?
Okay, so basically, from like that point, like the point right there, 47 degrees.
Yep.
Like since it's like the same, I said like EGD is 47 degrees too.
Measure of angle EGD you said was equal to what?
Measure BGA.
BGA. Yeah, you said 47 degrees, right?
Yep.
Well, what type of angle relationship do these two have? What do we call it? Vertical angles. You're absolutely right, Raya. These are vertical angles. They have the same angle measure. That's why we did it, right? Like I said, when I break down the information I'm given on the actual diagram, it makes everything easier. I see these are exactly the same. So if one of them is 47, well then obviously the other one's 47 as well. Liana?
Why are they called vertical angles if they're diagonal?
That's a good question. I don't know. I always, like the way I always envisioned it was because they're like across the street, like pointing at each other. Like I could do like a vertical line from this one to that one, but I don't know why they're called vertical angles. Yeah.
I did measure of angle BGE minus measure of angle BEE. I mean
BGD.
Oh, BGE minus EGD.
Oh. Okay. And what did you get?
I haven't done it yet, but that's what I thought.
Oh, I see. So you definitely could do that. I should have specified that these measures from number 1 are different from number 2.
Oh.
Yeah, so the only information we can use is that AGB is 47, which makes it easy because they're vertical angles. But the way you're thinking is going to help you on the worksheet for sure, Tyler, so keep that in mind. So yeah, 47 degrees is correct. Great job. Give me a thumbs up if that's what you and your group came up with, the same thing. Okay, some of us, not all of us. That's all right. Number 3, if measure of angle CGD, where is CGD? CGD, okay. If CGD is 3x plus 35 degrees, uh-oh. So CGD is 3x plus 35. You guys okay? Why are we all talking? Okay, and DGE is 3x plus 20 degrees. Bless you.
Thank you.
Solve for x and find the measure of CGD and DGE. Bless you. Yeah, maybe I mistyped one of these. Did I mean?
It would make sense if CGD was 62.
Okay. Let me try and figure it out. Hold on. What did I do wrong? $20, $55, $115, 6x. CGD? I messed something up. I don't know what I messed up. Tyler, do you have a question? Sure. What's up? No? Oh. CGD is this. Oh. Wait. What's 120? 120 minus 55.
It won't stay. Why are you using? It won't stay. Mr. Church.
Oh, it worked when I did it earlier. I don't know what I'm missing.
Exchange.
Oh, you know, I didn't do all those.
Is it? I don't know. I don't know what I messed up. I definitely messed something up. This image is like hurting my brain now. $55 plus 60? Okay. I don't know. Let's not worry about number 3. Let's just forget about number 3. I'll show you on the worksheet what we're supposed to do.
You get it.
Yeah. All right, take a look. So this is what the worksheet's going to look like. This is just to get us a little bit more comfortable with. Okay, never mind. You guys got it. You'll figure it out. That's not bad.